everyone. It's great to be the first one, I guess. So thanks everyone for coming, and let's kick off with some introduction and some stories from trenches around serverless architectures, and perhaps how they fare in the world of microservices. I'm Rafal Gancarz, lead consultant. For those who don't know me, you can get in touch with me using those contact details. Today we'll be talking a little bit about what serverless is and why would you want to actually try something as crazy as this. The state of serverless at the moment, some anatomy of the serverless system, so basically all the building blocks you can use, because it's very much a story about trying to build something with all the constraints that there might be in place. And then, some information about how to design or architect serverless systems, secure it, operate it, including rapid provisioning, all of the DevOps goodness, and then a look into the future of serverless, maybe based on some predictions or hopes in terms of how this area is going to develop. Right, so serverless is an emerging approach. I think looking at it, I remember when first ideas about, this is going to be a completely new way of building system have emerged. And I think it actually came to be not long ago, and also in quite maybe subtle way. There isn't a serverless manifesto yet, so watch the space. But at the moment, it's only sort of taking shape, and there are some, I guess, few adventurous companies who are willing to actually take the plunge and maybe work around certain, I would say, maybe level of maturity or lack of tooling or things that you have to actually do yourself in order to prop the existing platform. One of the key tenets of this approach is that you don't want to use any servers. So you're moving away from treating a cloud provider as a merely a remote data center with some nice APIs to actually still create your servers, deploy your applications. We know obviously quite well that lately the industry was moving from virtual machines to containers. This is actually completely changing the direction, I guess, and starting from a runtime being a service rather than you trying to actually provision the infrastructure in a traditional way. One interesting aspect also is that there is no runtime process for your programs to run in. So this is all given by the platform provider. And as I said, in terms of constraints, I don't think there's strictly a science. It's more of a notion that in order to do it in a way that embraces the cloud and the platform you are building your architecture on, you shouldn't be, unless you can actually help it, you shouldn't be trying to still pull the rest of the world, but try to do as much as you can just using all the services that the platform cloud platform provider gives you. I would even say that might be a true platform as a service. Obviously, it might not be very well received, but I think previous attempts to create platform as a service was merely a more streamlined way of still managing servers and containers. I think still the case to some degree. Obviously, we haven't been seeing a lot of these sort of systems because it's quite a new area. So perhaps there isn't that much history to discuss, and I bet there will be a lot of lessons to learn from this approach as well as from others. So no containers, no servers. How can you actually build anything? And why would you even try? For me, this is sort of a natural evolution of the cloud computing. So we started, obviously moving from bare metal to virtual machine, then going into cloud, and then the unit of composition, I guess, for the infrastructure, at least from the compute side, was getting smaller and smaller. We are doing containers at the moment, And that was very much driven by the advent of microservices, I would imagine. So the technology, I think, advanced and developed based on the needs of the community. Whereas with serverless, it's more about Amazon, being the first provider, have come up with the idea of just running some code, and they are taking care of everything around that. So I see it as a natural progression in terms of maybe miniaturization of the runtime unit or the unit of deployment, but also we are, I guess, also moving the responsibility for keeping the runtime up from ourselves onto a third party. So, with containers, for instance, we don't necessarily want to care about the fact that there are processes and applications, and you have to actually have all the buckets to run, or all the runtimes to run your application on, with functions that goes even further. Then it's built for fault tolerance and scalability. So because you don't have to worry about, well, you do have to worry to some degree, but a lot of the scalability concerns are taken care of by the cloud platform provider. So you just need to give it the code, and then it will, with some caveats obviously and limitations, it will take care of scaling up if needed. You pay for what you use. That's another thing. You don't have to actually over-provision, because obviously it's maybe not such a big problem in the world of virtual machines and containers and rapid provisioning. You can always scale up and down. But in this case, it's quite granular, and you only pay for actual execution of your functions. I would say it reduces the operational overhead somewhat, so there's no OS to worry about, no processes, no runtime environment, JVM. Who cares about JVM? Who cares about runtime? You produce some code. Obviously, it can invite some degree of inefficiencies, one might argue, but overall, you only care about actually putting together the code and then handing it over to the cloud provider to execute it. And the other thing is, embracing the cloud, I guess, being able to put together even more complex systems fairly easily without too much upfront investment. So you can actually have something, put it into market, paying perhaps cents. We'll see some cost information around specific services. There is quite a hefty fee here that you can actually dip into before you start paying for anything. Right, so this is all very nice, paradise-like. I think I have too many of my witty captions. Anyway, so it's sort of all makes sense, but obviously I guess it's not always as pretty as you might think. It's still quite a new area, so there is a lot of things that you have to actually work around, as you will see in a minute. In terms of the state of serverless, and I don't want to say it's only about lambdas, AWS Lambda, or sort of functions in the cloud. I believe there's much more to it. The fact that the AWS Lambda was the first sort of remote or maybe runtime as a service kind of offering, maybe not the first one, but at this level, I think that this is only sort of a catalyst for being able to actually start putting together more complex systems actually on this stack. But obviously, as you would know, there are lots of other services that you might need to actually build any type of business application. So, as you can see, still quite new. It's only maybe a year old from the official launch of AWS Lambda, and AWS is definitely a forerunner. I think the other cloud providers are only trying to catch up. So they've launched alternative solutions, but these are still in either alpha or preview, and I don't think people are going to be jumping to actually use them. I mean, AWS, as advanced as it is compared with other cloud providers, it's still, I don't think that the overall platform is as polished or as comprehensive as one would hope. So let's now look at some of the building blocks of the serverless application, and I'll be using AWS as an example, and perhaps the only workable platform that you might use for something like this. So the first thing is running your code. AWS Lambda supports Java, Node.js, and Python. You can run other interpreters maybe or runtimes in a sub-process, but then there are some overheads that you might not necessarily want. So maybe not necessarily very encouraged. The entire processing model is based on events. So whatever you are handling, it's going to be seen by your Lambda code as an event. And these might be events coming from, let's say, API gateway, being an HTTP request you need to handle, or it can be a genuine sort of a message coming from the queue or topic or from a stream. But you don't necessarily have to worry about how those events get to your code. This is all taken care of by Lambda, and it uses different models, let's say, either by services pushing events to Lambda or pulling, depending on how they would work internally. But from the point of view of the developer, it doesn't really matter. An event arrives, the Lambda is invoked, and your code is handling the event. They will look differently depending on the type of the source. So that's maybe one of the caveats, because you have to know what sort of event it is. There is some degree of I guess, commonality in terms of the interface, but at the moment, maybe the entire model is not as consolidated as one might hope. Lambda integrates very well with identity and access management service, so your code can be executed in the secure environment. You can only give your Lambda function access to specific other resources, so that's pretty fine-grained. And in terms of the cost, obviously, pay per use, and you have 1 million invocations for free before you start paying for it. So it's at least worth playing with, I would imagine. But even considering, well, unless you're actually trying to run another Twitter or something like that, you might actually go quite a long way without actually paying anything. And if you consider, for instance, that another good practice is to actually have a separate environment, so a separate AWS account per environment, then I guess you can even spread the costs even more. So maybe the production one actually seeing production traffic will be the one that you'll be paying for the most. Outside of free tier, it's still quite cheap, 20 cents for million requests, and I've actually calculated the cost of GB seconds. That's an interesting factor. So you don't provision infrastructure, but obviously running code takes resources. So the way that you are charged is a combination of how much memory your Lambda might be using and the execution time. And that's rounded up to the closest hundredth of the second. Not 100 milliseconds, sorry, so 10th of the second. And then there are different tiers for pricing as well. So overall, not very expensive. Then I guess if you want to actually expose this Lambda function, which might be buried somewhere in your AWS account, you have different ways. One way, obviously, is you can invoke it directly. But if you want your system to be looking more like maybe not necessarily microservice-based one, but something that can be consumed by third parties or by UI clients, you certainly want some APIs. So this is where API gateway comes in. And interestingly enough, this has been devised as a API gateway, not necessarily as an API layer in front of your Lambdas. It just happens then you can actually attach Lambda to it, so now it can be used as a facade of your service, let's say. So originally, and still is the case, it provides API management, security, caching, auditing, but except for actually being able to put the API gateway in front of APIs running maybe on EC2, you can also use Lambda as an integration type. The caveat is that it's still a gateway, so there's a lot of fat basically just to manage the gateway capabilities, and because it's meant to be used, let's say, for model mapping and maybe caching and other things, you maybe not necessarily be able or be interested in using those capabilities if you want to use it for serverless. Again, not very expensive, but I don't want to spend too much time discussing the costing details. So then we've got persistence solutions, and obviously, yes, you can use any of the relational databases, because not for a long time now Lambda has got access to VPC-based resources, so you can interact with anything that is actually running in your VPC on AWS. But I think maybe the truest to the sort of serverless idea would be to use something that is actually delivered as a service. And I think DynamoDB would be the first candidate. There's also SimpleDB, but maybe not as capable, because that was the first attempt to have a persistence or database as a service by AWS. So with DynamoDB, you get a document or key value data model and consistent performance, highly scalable, and pretty fine-grained access control. So you can use it to actually store your data and retrieve it. It supports queries, indexes, maybe not as straightforward at first to use compared maybe to traditional relational databases. If you've been relying on those to actually give you optimized queries, you have to do a little bit more work here, like with other NoSQL databases. Create secondary indexes, for instance, to optimize your queries, and also be quite mindful about the schema definition, so it's actually optimized for querying. We know all of that from Cassandra, let's say. One interesting aspect that where also can be actually integrated with Lambda is that you can actually attach Lambda as a trigger handler for any changes to the database. So I know perhaps from my own experience that database triggers were not very weren't the favorite tool of developers, because mostly they are sort of managed by DBAs, so it was difficult to persuade anybody to actually maybe put them in the first place. But also, once you actually decided to use triggers, there's no way of escaping from the hands of DBAs. No DBAs here, I hope. Nothing against DBAs, by the way. But in the context of DynamoDB, this offers a pretty interesting capability, and interesting enough, it was. Oh, really? Okay, I better get cracking then. Well, okay. Then we have S3. You know all, and you know S3 perhaps pretty well. One interesting capability around Lambda is, again, you can attach Lambda function to actually process some resources or files stored in S3. SNS, publish, subscribe, Kinesis for data streaming. Apologies, I need to speed up a little bit. Then you have everything else, and actually I forgot to put Route 50 for DNS, and let's say CloudFront for content delivery. So you can draw all of this, and then anything else that runs in VPC as well, if you can't find anything else. So you've got all these building blocks, right? Now you don't want your system to to end up like something of that kind. So how do you go about actually designing an architecture that can actually work? And maybe, if you consider some simple use cases, it's not a big deal. Slap API gateway, Lambda, maybe DynamoDB or S3. You can create a Slack bot. You can create something fairly simplistic. But what happens if you need to actually create an enterprise-grade systems with multiple business areas, and you don't want to end up with something like a monolith in the cloud, right? Because it's only maybe too convenient to just keep adding things on the periphery, and then you'll end up with sort of big ball of mud and a lot of tight coupling. So I think my principles or best practices that I've been trying to use is basically make sure that we are modularizing the system around business areas, those being quite cohesive, good encapsulation, no reaching to other systems data persistence layer, for instance, having clear interfaces and flexible message formats so we can actually evolve the platform as it changes, and asynchronous messaging for any cross bounded context notifications or messaging. I wanted to sort of remark on how that compares to microservices, and I think in general very similar goals or objectives, but different paths. Microservices, I still believe it's a lightweight SOA. I won't be persuaded otherwise. With serverless, basically it's more like, okay, there is this rich platform ecosystem. Why can't we just use that and that alone to build even complex systems? There are certainly similar challenges around both of these, inter-service or inter-module dependencies. How do you evolve the complex system? Operational complexity, obviously, quite similar, like in the case of microservices. So the idea of having a lot of services, simple services, is great, but there's a lot of complexity actually to go with that, to manage it all. And then obviously security. In terms of development, choosing the runtime. On the project that we are working on, we decided Java was way uncool for this new technology stack. So we actually initially went with Node.js, and we still have plenty of Node.js code. But then gradually, actually now we are in the process of maybe moving to Python, because eventually it might be easier for clients developers to pick up, we figured. But regardless of your runtime language, you still have to take care of packaging function codes and dependencies, so dependency management, code reusability. You don't want to be duplicating a lot of code in various Lambda functions. And I guess in general, ease of adoption. So choose the language that actually you can support longer term. There are few of different frameworks that might be, different level of suitability depending on what you want. We are using Apex at the moment. We have played with serverless, Cloudia maybe not as much. What about security? This is perhaps one of the areas that is quite well addressed by AWS. I think everything is in terms of authorization at least, everything is access controlled. So and this is based on policies. Sometimes you even are tired of actually creating policies specifically for every single cog in your architecture. For authentication, you can use ID secret, API keys as well for API gateway, secure token service for granting privileged access temporarily. We are using separate AWS account per environment that helps separating different environments. So obviously nobody gets access to production, for instance. And we have a master account for actually being a sort of a bastion for accessing all the other environments. How do you actually operate such a system? So, infrastructure provisioning. Similar challenges to maybe to microservices type solutions. You can list them all. The interesting thing is, obviously, with multiple accounts, you have to take care of that. You want to separate banded contexts into separate stacks, but you still have to manage interdependencies between those. You might have some post-provisioning tasks and global namespace resources like DynamoDB tables. Perhaps you have to maybe prefix them if you want to have any degree of organization there. And obviously the orchestration in terms of deployments. So we tried CloudFormation and subsequently decided to actually swap it for Terraform. And at the moment we actually we are using Terraform. Although we have sort of bespoke config generation solution, maybe we'll be changing it to use Terraform templates at some point. But it's working very well. Supports API gateway, which CloudFormation doesn't. Continuous integration delivery. AWS is going to force you to use as much of their stuff, right? But it still helps to actually have local way of actually running your code and also testing. I saw some blog posts from AWS saying, use AWS Lambda for testing Lambda. But then, how do you do that on your continuous integration server? So I think we've been inventing a lot of traditional quality measures and practices actually, and trying to apply those into AWS Lambda. But obviously, there's still a lot of work that you need to do in that area. And then monitoring, logging, auditing. We are using services from the platform, and I think that might be one of the areas that you get actually quite a lot out of the box. There's still some work, obviously, in terms of, let's say, setting up the log aggregation stack, but things like CloudTrail and CloudWatch metrics are actually covering the basic application metrics you might want. The future of serverless. I think the current challenges are definitely, I don't see that the platform is actually as capable as it should be, as streamlined, because it was just put together. Don't think that AWS ever actually went on the journey to create a platform for something like this. They were just introducing individual services, and once Lambda was available, someone decided, well, now we can actually start building even complex systems on top of this platform. So the tooling is seriously lacking. You have to invent quite a lot of things and maybe try different things to see what works for you. And patterns and practices maybe are not there. You won't find a book on serverless, for instance, because such a novel area. My predictions and hopes. I think it's certainly going to be evolving, and providers, not only AWS, will be investing more and more in that space. It might be the future of computing. I see it as a natural progression, as I said, and I think with the entire space maturing and being better supported, I only see building systems using this approach becoming easier and easier. So maybe at some point we'll be all doing that. Happy days. So thanks to Roger and Mark, and David and Vincent as well. Any questions? I'm available later. One question, please. Sorry? Oh, yeah. So the question was, is there any tooling or any existing practices for documenting such an architecture? Well, I think that the usual rules apply. It's perhaps as difficult to document a complex system built on top of the stack as it is to document, let's say, a more traditional system using microservices. because there is a lot of interactions between different components. You want to document APIs as well fairly well. You want to document all the operational aspects. So we are using, no surprise, a wiki at the moment. It's definitely not as well documented as it should be, as is always the case. But I certainly would like, I mean, there are lots of areas where the maturity in terms of maybe also documentation actually is lacking, because we are inventing a lot of things as we go. So the quick answer is there are no patterns or tools at the moment. So common sense, basically, and a lot of work as well. Thank you very much.